That is what the link to the videos for the class, right, that I have here. When you click on it, it takes you here to this playlist. And, whoa, jeez, sorry about that. And the reason I wanted to bring this up is because last class I asked, how many of you have seen antiderivatives? Everyone was like, so in case you want to go back and get a more thorough, like, let's go step by step through antiderivatives, power rule and all that stuff. If you were a little too shy to ask for help during class last time, go to this page, go to Robert Math Guy. That'll take you to my YouTube main page. And then there's Cal 1 is the first list of videos, Cal 2 is the second list. And you can see here, somewhere here, Cal 2 Internet Lectures. If you look at that playlist, you'll see here a section here on antiderivatives here. So I spend an entire class period talking about antiderivatives. And so I just want you to know it's there in case you want to go look at it. Because I pretty much have jumped right into substitution. So, yeah, questions? Questions before I begin? Anything homework-wise or anything like that?
Oh, I wanted to ask.
Yeah.
One of the problems, I want to say it was in the 30s, it had, it was C plus D equals 0.
Uh-huh.
I don't forget what the other one was, but it was system of, I forget the vocabulary word that you used to describe
System of equations?
System of equations.
Yeah.
Yeah, do you have other videos on that?
Yeah, I would refer to, were you here just now or did you just walk in? You just walked in. Okay, so I was just pointing everyone to just go to the YouTube channel for our playlist videos.
Yes.
And then click on Robert Math Guy, and it'll take you to my main page, and then go to Cal 2, and then lecture videos, and then go to 4.7, and I go through some more detail on that.
I just watched 4.7 this morning.
But that was from,
I think it's pre-cal, right?
oh, how to solve systems of equations.
Yeah, more videos on that specifically.
I don't know if yeah, it's a college algebra topic. I don't know if I have anything. I'd have to go search.
Okay.
Yeah, you might be better off just go to YouTube and search solving systems of linear equations. 2 equations, 2 unknowns. There's 2 methods, substitution and elimination. Elimination I think is better, but whatever you like. If you need help, let me know. I'll help you. Okay. Anything else? So what we were doing last time is we were saying, all right, we want to be able to try and find antiderivatives, right? Using this thing called substitution, which is this method where we look at the integrand, we look at this integral, and we try and see something, and we try and find its derivative, but the derivative of it, we should make sure that that derivative is in the numerator, that it's not trapped, blah, 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 right? And then you just make a substitution, you try and make it work out. So we're going to do a few more examples, and then we're going to move on. We're going to get into 6.1. So here we go. And I think we'll just start with a warm-up one here. There you go.
You said this is 6.1?
No, we're going to start 6.1 today. We're still in 5.5. I came this close to giving a quiz today, and then I held off. So I would expect a quiz on Tuesday.
Day before the test?
Day before a test. Yeah. Just to give you an idea, I want to give you an idea of problems, you're going to be studying anyway, so it should be easy. Easy, you should be totally prepared.
Oh,
Yeah.
Sure. That's how I went last semester too.
All right, here we go. Well, so you got to find something, right, and hope to see its derivative.
Maybe 1 plus e to the 2x.
1 plus e to the 2x, perhaps. Let's try it. Let's see. Today is the 26th, right? Yeah. I'm going to pass this around. There we go. Okay, let's see. We're going to try. Let's try 1 plus e to the 2x. U is equal to 1 plus e to the 2x. If we take the derivative of that, what is the derivative of that? Careful. So derivative of 1 is 0, right? Derivative of that is itself times, chain rule, times 2, right? Times 2. You good? You don't understand that?
Yeah, I don't see that up there.
You don't see that over there? Let me multiply both sides by dx. I'm going to stop doing this du over dx, and I'm just going to start putting the dx on this side every single time at the beginning rather than having to move it. So remember, we have chosen to let this be u, right? So you're no longer allowed to look at that. That means the only thing left for us to look at is this, e to the x dx. And look at what's here, e to the 2x, and then times 2. The times 2 isn't really the problem because we can be off by a constant. And the dx is there. So the big problem is that 2 right there. We don't have that, do we? So if we don't have it, what do we do? Yes?
Technically, e itself is a constant, right?
Well, e to like the first power, e squared, but not e to the x. E to the x is a function. It's not a particular value unless you plug something in for x, right? Yes?
So, are you gonna, can't you pull e to the x out and then make a 1 over?
Over here?
E to the x squared.
Well, like, yeah, so you can make it e to the x over 1,
Yeah.
and then you'll have 1 over 1 plus e to the 2x, which is the same as the tangent inverse, right? Is 1 plus, or 1 over 1 plus, like, x squared essentially. I worded that right.
I'm like halfway agreeing with you. Are you wanting me to stick with this, or are you wanting me to look at the problem completely different?
Rewrite the problem.
You want me to do it a different way?
Yes.
Okay, so hang on that. Let's agree. Did you have something you want to say?
I was going to say, like you said, e to the x squared.
Oh, rewrite this as e to the x squared in the very beginning. So you're suggesting a different approach as well. So let's first agree that this can't go any, like there's nowhere we can go with this, because we need to somehow get this replaced with something that has u's in it, and the only thing we can use is this piece right here, and this has an e to the 2x, not an e to an x, right? So there's no way we can't just like get rid of that 2. You all see that? So this isn't going to work, which is okay. This part of this whole thing is us making mistakes. Hold on. Is us making, trying something, right? Trying something, and then saying, you know what? I see something that might work better. You understand? Okay, so it's good. We would not crumble this up and throw it away. We would just move it underneath and start over. We want to be able to go back and look at our different attempts, so that we can learn from the things we did and things that worked, things that didn't work. So I'm going to start over. And the suggestion I'm hearing is to rewrite e to the 2x as e to the x squared. I think that's the suggestion I've heard. Yes? Now that should work. Question?
Well, I'm also just thinking, couldn't you have made the 2x the u, because then you get e to the u, and you have e to the u up there, or no?
You wouldn't have e to the u up here because this is not u. You said u was 2x, right?
Okay, yeah.
So that wouldn't be e to the u. This, if you were going to do this, what do y'all want me to make the u? Just e to the x. And then what's the derivative of that? Itself dx, right? Like that? So you no longer have the 2 problem because you've rewritten the e to the 2x as e to the x squared. And now, Let me just kind of pull this apart so we can really see it. All I did there was just slid this e to the x out to the side like that. And this right here matches exactly, right? These match exactly, perfect. And then, of course, this here is our u. Yes?
Isn't the best approach to always like separating it?
If you're having trouble seeing that it is, you know, like, if you look at this and you don't see that this is that, then pull it to the side so you can really see it. You don't have to do it, but until you get real comfortable with it, you might want to just, you know, pull things apart and isolate the things you're looking at.
So,
Yep.
I was going to say, so my understanding is if the power of the numerator is less than the denominator, will you always run into a situation like that?
I'm not, yeah, I can't say that, unfortunately. There's not like a rule, like, you know, it's always going to be this, or, yeah, unfortunately. Yeah, just, I mean, if there was, I would give you the rule, but there's no like, we just have to, in this method, we have to look for something, look for its derivative, see what happens. So now I rewrite the problem, right? 1 over 1 plus, that was u, so u squared, and that was exactly du, so du. And that we should recognize as being the antiderivative of that as being what? Tangent inverse. So we're going to put tangent inverse of what? U, right? Tangent inverse of u plus c, because we've actually found the antiderivative. And one more step, because we have u's in our answer, and we don't want u's, we want things with x's. What was u? E to the x plus c. There we go. There's your antiderivative.
You said we can check out the du like becoming c.
If you want to, yeah. If you want to know, like, where did that go, just make it become the c. All right. Ready for another one? How about, I did one similar to this last time, but I'm gonna do it slightly different this time. Or I shouldn't say I didn't do this one. I put one on the board at the end of class, but I never did it. I just told you how it might go, but I actually never finished doing the integral. So we'll wait on that one. This is like that, but not the same one. All right.
So, would you be wrong by like trying to rewrite it just off the bat to like negative exponents?
You can do anything you want. I mean, as long as it's legal algebra, you can do whatever you want. But I'm going to start by just looking for something in its derivative. That's the way I suggest you start. Hopefully we don't need algebraic manipulation like that. We can just see it, maybe not. Do you see something? I don't want you to tell me if you do. You do see something? Okay. Let's see if we get a couple of people on board. You see something? Yes? I'm going to give everyone an opportunity to see if they can figure out what the something is. Okay. Show of hands if you think you have the something. Just trying to see where people are. Okay. Show me your hands if you're not sure. Come on, it's okay. Don't. No. We don't care, okay? We don't care. We want you to learn, right? Everyone wants to learn here. So let me help you a little bit. Okay, let me help you a little bit. Let's see if this helps. If you're not seeing it, see if this helps. Okay. And even if you think you had it, maybe that changes your opinion of things. So by me separating it like this, for those of you who are having trouble seeing it, this I'm kind of implying is the derivative of something, right? But I'm off by a constant, maybe?
squared is then add the square root of x.
Square root of x, right? So you'd have to know from Cal 1 and from your comfort level with derivatives that the derivative of the square root of x is 1 over 2 times the square root of x. Now I know a lot of you in Cal 1 learned like to do this. You do, that to the half, and then you learn that that's 1/2 x to the negative 1/2, right? How many of you learned that way? Okay? It drives me crazy. All right, this is the way it should be. I mean, not that it's wrong, it's right, but this is the way we see it in Cal 2. We see it in this form, and so it's easier to go backwards if we're used to seeing this than it is here. You know what I mean? So this, we need to see that this is, in some sense, the derivative of the square root of x. We need to see that. And if that's the derivative of the square root of x, then it makes perfect sense to let that be u, right? But more than that, it makes more sense to let that be u, the 1 plus the root x. Yes?
I thought it had something in the numerator, though. That's what
No, the something doesn't. Oh, you're saying, this right here?
yeah.
This is in the numerator. Because look at that, that's the derivative, right? Right there? What the hell's going on? Hold on. This is the derivative, right? It's a fraction. So it's going to have stuff in the denominator, isn't it?
I see.
You see what I'm saying? Like that written like that is not in the denominator. That is the derivative. I know what you're saying. You're seeing the root in the bottom. You're saying, wait a minute, derivative is in the bottom. No, it's not, because the derivative actually has a fraction in it.
Yeah.
So it contains a denominator. It's not in the denominator, though. Yes?
I was going to say, so that was my guess for you initially.
What, square root of x or 1 plus root x?
1 plus root x.
Okay.
My question was, so my idea is, or my idea, but the idea behind grabbing the 1, 2 is because you mentioned, I think you mentioned something before that you want to grab as much as you can. Like, is that the logic with that?
Yes, exactly. I want to grab the 1 because grabbing the 1 doesn't change the derivative at all, right?
The one's just going to disappear, right?
It's going to disappear when I take derivative.
That makes sense.
Okay. So there's our u. Our derivative now, we take our derivative. The derivative of 1 is 0. Derivative of the square root of x is 1 over 2 root x dx. I have already pulled it apart for us so we can see it, right? Already pulled it apart. What are we missing here? Or what's off? This 2, right? We want this, right? We want that right there to match with this. This has a 2, that doesn't. So I'm going to manipulate this over here. I'm not going to mess with that, I'm going to mess with this. So how do I get rid of the 2 down here? Multiply both sides by 2. So I do 2 here and 2 here, multiply. And they'll cancel out on the right. So now we have 2 du equals 1 over root x dx. So now they match, right? That matches with that exactly. And we also have that this whole thing, right, is this. So that will be replaced with u, won't it? So we're ready to go. Rewrite the problem, integral. This becomes 1 over u. And then times the red becomes 2 du. I'm going to put the 2 on the very outside front because constants, just like in Cal 1, constants will just continue to come with us whether or not we're differentiating or doing antiderivatives. The constants will just come for the ride. So the 2 is going to be out here, and then I'm going to put, what was it? Du? Yeah, du. And that should be something we can handle, right? The antiderivative of 1 over u, natural log, natural log. So we're going to have here no more integral sign. 2 comes for the ride. Natural log, absolute value of u plus c. Again, if you want to make that du go somewhere, make it the plus c. And then this is equal to 2. We're not done. Absolute value, 1 plus root x plus c. Now I'm done. And you could check the answer, right? If you wanted to, you could differentiate this. Any questions or anything? Yes.
So it's a little bit random, but I've been wondering if you can, so like on the denominator, kind of, not originally, like when we made it 1 plus square root of x, are you allowed to kind of look at sums and differences as like within an interval? You look at it like individually, you know how like limits, like you can do like, you had a limit of two, two things that you were adding.
Mm-hmm.
Like,
You can do them each one.
you do the same kind of thing with integrals, like
You can only separate integrals if you have addition and subtraction. You can do antiderivative each one separately. But if you have multiplication or division, you cannot.
oh, okay.
Right? Which is what I was saying causes the big problem here for us. Like if we could do them separately, then that would be great, right? We just pull them apart and do each one, and then everything would be great. But we can't. Yes?
What was the equation to do the antiderivative for when the power is -1 again?
Natural log?
Yeah.
Is it
-1. There's only one exception. It's when x is -1, and then it's natural log. Any other negative power, you're just going to add 1 to the power, and
so? What do you mean natural log? Like you take the derivative like of natural log?
no. If you had, let's say you were trying to find the antiderivative 1 over x to the 3rd power. I don't know if this is what you're asking me. But if I'm trying to do that, the answer is not natural log, because that's not 1 over x. This is really x to the -3, isn't it? And so the antiderivative of that, I use the power rule. The power rule says that the antiderivative of x to the n is 1 over that power plus 1, right? -2.
My question is
X to the negative.
Simple. It's just what's the antiderivative of x to the power of -1? Like I forgot how to.
It's natural log. That's the one time that rule doesn't work. The one time this property doesn't work is when x is -1, or when the power is -1. X at -1 is 1 over x, right? The antiderivative of that's natural log.
Oh yeah.
Yeah? So that's that, which is that one exception where we don't use the power rule. Yeah?
I just don't know how to like write the equation for that. Because like I have the power rule. It's like 1 over n plus.
It's on the formula sheet. It's actually on there, yeah.
I tried
Yeah.
listening. I couldn't find it.
Yeah, no, look at the page 6. Number 3? There. They write it a little different. They put du on top, but. All right, let's do another one. This sort of thing is, I can sit here and put problems up all day, right? But that like instinct of what to use for you and things like that comes with just a lot of practice, all right? And the concept is there. You know what you need to do. It's just doing it now, right? So let me give you another one. Get my glasses out here. This is an interesting one. I like ones like this. I'm kind of a big fan of these. I like problems like this because it looks horrific. But no, it's not because of that. It's actually because there's you know how with the square root, I really want people to understand that the derivative of the square root of x is 1 over 2 root x, and that you could see that if you, like in there, like the previous problem, right? You need to see that 1 over root x was the derivative of the root x. You were off by 2 or something. This is another one of those ones where I would hope that a Cal 2 student would see that derivative and not have to like do it by hand. So let's do the problem so you can see what I'm talking about. I'll give you a minute to look at it. And then we'll do a show of hands. How many people think they have U? One person? 2? That's the same problem, right? Just took that x squared off the bottom to the side as a 1 over x squared. All right. Let me know. What do you think? Who thinks they have u to sub? No? We still have the same? Think you? Think so? Give people a little bit more time. For those of you who think you know what it is, what is it that is very helpful to know the derivative of? 1 over x. What is the derivative of 1 over x? Not the antiderivative. What's the derivative of 1 over x? Well, that's x to the negative 1, right? Take its derivative, what do you get? Negative 1, bring the power out, right? Negative 1, x to the negative 2, right? Which is really what? Negative 1 over x squared. Hey, so if you recognize the fact that the derivative of 1 over x is going to somehow turn out to be like a 1 over x squared, it's going to look like that, then it's easier for you to see that somehow the derivative of this in here is connected or related to that. Do y'all see that? Derivative of this is somehow related to that. Now, if you are completely like, I don't see that, I didn't see that, well, then you're in another boat, which is, well, you got to try something. I mean, you can't just give up. You have to try something for u, right? So looking at this, there's a couple of things you could use for u. How about x squared? What's the derivative of x squared? 2x. Do you see an x? I see an x right there, but what's wrong with it? It's trapped. It's inside a secant function, right? So I can't do that. And there's not a whole lot else for you to use for u, right? Other than this argument that's in here, 3 over x. So let's try it. 3 over x is going to be my u, which remember is the same as 3x to the negative 1. Now when I take derivative of that, somebody tell me what my final result of the derivative of that is written in more of this manner, not with negative exponents and stuff. Negative 3 over x squared. Dx. Now we're Cal 2 students, right? So you do want to be at a point where you can eventually get to here to here should be a mental exercise. Not maybe today, but like, you know, this should not be this huge part that takes 15 minutes to figure out on the side. It should be a much more, and I'm only telling you that because I need to be honest with you. Like, if that takes you forever, where we're headed is going to be trouble, right? I'm not trying to scare you, I'm just trying to be real with you. All right, do you all see this? There's our u, right? There's our u right there, that's u. Do you all see this in there? Are we off? What's up?
We're off by 1x in the denominator, right?
Yeah, we're off by the negative 3, right? We don't want that negative 3 here. This just has a 1. So how do I get rid of the negative 3? Well, I'm going to just work with this, though. I'm going to get rid of the negative 3 here by multiplying both sides by negative 1/3, or divide both sides by negative 3, however you want to look at it. I'm going to do multiplication by negative 1/3 du, which will eventually come out, okay? And then that'll turn into a 1 over x squared dx. See, this is just like a matching game. We're trying to get things to match up, right? That matches. And then, of course, this right here was our u. What is the new integral? Secant squared u
Times negative 1/3 du.
secant squared u times negative 1/3 du, right? And I'm going to pull the negative 1/3 out, put du right there. Do we know the antiderivative of secant squared? Tangent, right? Not inverse tangent, just tangent. So we have negative 1/3 tangent of u plus a constant, negative 1/3 tangent of, what was u? 3 over x plus c. There we go. Y'all doing all right? This is not a trick question or anything. I'm going to try and develop an idea here for you. What's that? Sin x, right? Sin x. No tricks there, just sin x plus c. All right, now I'd like to know what the antiderivative of cosine of, let's say, 3x is. Sine of 3x what? Plus c? Let's try that. What? Sine of 3x plus c. Why does that not work? Because of chain rule. If you take derivative of this, you get cosine of 3x, right? But then times 3. And we don't have a 3 here, do we? So in order for this to work, what would you have to put out front here? 1/3. Right? You'd have to scale it. Now I'm doing that just mentally, like I'm understanding how that works. You could technically do a u substitution here. You could let u be 3x and then go through the work for this to show that that's that. But I think we can do this. I hope that people can follow this. That we need 1/3 here so that when we take derivative of this with chain rule, the 3 that pops out will get killed off by the 3rd. So how about if I do this?
Negative 1/2 sine of negative 2x.
Yep.